but where you're going to find the material is going to be right here under modules. What you want to do is sometimes on your Canvas page, these things will open up. Just close them so that it's easier to navigate, and you just click on these triangles, they're called chevrons, and go to the week that pertains to us. We are on the 8th week, March 24th to the 26th. And what you see right here is the pages I've created since we've last met, so that you guys will be able to carry out the lab experiments online. You see this circle right here? It means that that hasn't been published, and you guys don't see that. So if I go under student view, you can always go under student view and kind of see what you guys are looking at. Okay, if I do student view, then I should be able to see the pages that you guys see, and to make sure that everything is in the correct format. So I'm closing these because these automatically open under student view and I don't need it. We've passed all these experiments. Okay, so we're in the 8th week, and you can see that that previous session that we had that I showed you that wasn't published is not here. But this is what you guys will see, and just so that you understand what's on these pages. The Zoom session from my other classes right here, and once we are finished, I'll also put the Zoom session for this course right here as well. So if you click on this, it automatically takes you to a YouTube site, so that if you have questions or you want to see the pre-lab discussion again, you can access it. So I'm going to change that. I'm going to peek at my other screen every once in a while to see if there's any chat questions. I saw it earlier. Okay. I saw earlier though, as I completed the pre-lab quiz and the pre-lab questions. Okay. So let me just show you what you guys have to do before Sunday. You guys have your, even though it's open up in the beginning of the week, you guys have till Sunday to complete everything and turn it in. My Tuesday class have until Friday. So you guys have the same amount of time from when you meet to when you complete it to do the assignment. So under module, let me just do this real quick. We're going to go to week 8. And again, this is where you're going to see the Zoom session for the pre-lab discussion. Right here under empirical formulas and introduction, I basically took your lab manual and copied it on here. So it has the verbiage of the experiment that you guys are going to be doing this week. Okay. I'm going to close that. This is the PowerPoint that is generally my pre-lab discussion. And if you don't want to download the PowerPoint, you can always watch the movie by clicking here. And then you can control the speed by just moving across the timeline down here. Okay. Of course, this movie doesn't have any voiceover, so you want to go into the Zoom session, but that is basically the movie of my PowerPoint. I'm going to close this, and I'm going to talk to you guys about the pre-lab discussion later on, like shortly. But I just want to show you the different pages here. So in the introduction, that's where you get the information. The pre-lab quiz, this is similar to the pre-lab quiz that we have before class. Once you open this, you have 10 minutes to complete it, okay? Take the quiz. Even though it says it's due March 26th, which is today, you can turn it in as late as Sunday. But once you open it, you're committed to complete it because it'll close on you after 10 minutes from when you open it. So I'll give you a peek of what this quiz is. And it's basically the same type of format, except I've taken the quiz and made it multiple choice here. Okay, so these are the questions that you have in the quiz, and you have 10 minutes. So make sure that you read the experiment before starting on this, because you only have 10 minutes, just like we have in class. Let's go back to module. Okay. Then after the pre-lab quiz, you have a pre-lab questions. These are not timed. The rest of these are not timed. Only the quiz is timed, just like as if you were in the lab. Here, you have the pre-lab questions. This is the same questions that you have in your lab manual, except what I've done is, instead of making it open-ended, I'm giving you choices. I'm making it a multiple choice. It's much easier that way for me to grade and for you guys to get your results back. So when you complete this and everyone has completed it, then Canvas will automatically grade this rather than me hand grade it. So these are the same questions that are in your lab manual, okay? Except for the last one. I've changed the numbers, so you guys might have different versions. But if you know how to do the calculations, which I will show you here today, then you should be good to go.
Professor?
So, yes.
Are we gonna get the answers to this pre-lab question?
Yes, once it's graded, you go back to the grade and you click on your score, and it'll take you back and you'll see which ones you miss.
Okay.
Okay. So that's after it's graded, and it's generally graded after everyone submits it.
Oh, okay. So I have to wait until the 29th?
Yeah, you have to wait till the 29th, but at least you'll get it before your midterm. Okay. So we just have to work it that way, because
Okay.
it's been known that someone will look at the answers and pass it along.
Okay.
So let's go back to the module. So those two are through Canvas. Okay, you don't have to submit your paper for the pre-lab questions. You take it through Canvas. Now, the main part of the experiment is the empirical formulas video data sheet and the data. I'll talk to you guys about this shortly, but I just want to introduce you to this page. Let's go back. And then when you've compiled watch the video, then you need to submit your data sheet. This is the page where you submit the data sheet, empirical formula, upload data sheet. And then when you complete the data sheet, you want to complete your post-lab questions for that experiment, and this is where you upload it. So you have 4 places where you guys are going to be graded: the pre-lab quiz, the pre-lab questions, those are done through Canvas. And then the data sheet, that's where you write your observations and answer the questions based on the video. And then the post-lab questions, you have to upload the file. And then remember experiment 5, that was before we all kind of exit quickly. Some of you turned it in. Go over here, click on that, and then submit your experiment by clicking on that. And then what you want to do is browse your computer to find the file, find your file, and then upload it, and then I will get it. That's basically what's going to happen for the rest of the semester. You guys are gonna, for those things in which you complete on your lab manual, you need to take a photo, or you need to scan. I doubt if many of you have scanners, but there's actually apps out there that allows your phone to act as a scanner. I'll send you those apps. And then the main thing is that the photos need to be compressed to one file, or the photos need to be pasted in a Word document or some document, so it's one file, because you're only allowed to upload one file. I haven't figured out a way to figure out how to do multiple files, but if you compress it so it's one file, then you can upload it here. So this is where you upload your post lab for the last experiment, experiment number 5. Okay. The deadline for the post-lab experiment 5 by tomorrow, Friday. Okay, you guys had like a week and a half to do that. It was originally due the week when you get back, but because we had the whole week suspended, it would have been due today. I'll make it due tomorrow. Okay. And once I get that, I'll grade it and then I'll post your total score for that experiment. So let's go back and let me tell you how to complete this experiment. Okay, I'm going to get out of here. I'm going to leave the student view. And this shouldn't take more than 15, 20 minutes more. This is just like a pre-lab discussion. This is you guys are gonna do 2 syntheses and then you're gonna determine the empirical formula. Remember what the empirical formula is. It's basically the lowest ratio by which the element for that compound exists. So this lab is to determine the empirical formula of 2 compounds using 2 different methods. A magnesium oxide compound and a copper chloride compound. If you were in lab, I would say never look at, be careful of hot objects. They look like they are cold. Don't ever look at the magnesium burning and don't use excess amount of zinc. Okay, these are the pre-lab questions. This reaction, copper and sulfur, and gives you copper sulfide. It's a black chemical. This right here is another experiment. And in this experiment, I'm taking nickel, I'm reacting it with oxygen from the air, and I'm getting 5.093 grams of the nickel oxide compound. You don't know the formula, and that's what you guys are going to be determining. You guys are going to determine in this reaction or in this experiment. So I know the mass of my nickel. I know nickel compound. This has nickel and oxygen. I know the mass of the nickel, so the mass of the oxygen has to be the difference. So what I've done is I've taken the mass of my nickel, which comes from my starting material right here, and I figured out the mass of my oxygen, which is the difference between the compound and the nickel. And I've taken the mass of the nickel, divide by the atomic weight to get the moles of the nickel. I've taken the mass of the oxygen, divide by the atomic weight to get the moles of the nickel. These mole is the ratio by which these atoms exist in the compound. So I need to make these whole numbers. I will take a look at both of these and look at the smallest one and divide both numbers by the smallest ratio, the smallest value. And if I divide this by 0.0382 and do the same here, okay, what you find is that, I apologize for my finger pencil here, then the ratio that you get is a 2-to-1 ratio. So therefore, if I have 2 nickels for every 1 oxygen, remember oxygen's -2, the nickel has to be a +1. So the correct formula is Ni2O, and the correct name would be nickel, parentheses 1, oxide. So that's a type of calculation that you guys will do in this lab. You guys are going to have 2 elements, especially the magnesium and the oxygen. You know the mass of the magnesium, you know the mass of the oxygen, come up with the formula. So this is what is going to happen in the experiment. You take magnesium, you burn it in oxygen, but in air, there's also nitrogen. So you also form this chemical called magnesium nitride. You don't want that chemical. The way you remove that chemical is you add water to it. The magnesium nitride will form ammonia, and the magnesium will react with oxygen to give you magnesium oxide. So this is some data that was collected, say, for this experiment. If I start out with 2.43 grams of magnesium, and I get 120.060 grams of magnesium oxide in the crucible. This includes the mass of the crucible. What is the chemical formula? So let me show you the procedure real quick. You start with a crucible and a evaporating dish. This is the crucible, this is the evaporating dish. What you want to do is you want to turn on the Bunsen burner because you're going to need really hot conditions to ignite the magnesium. Okay. So basically inspect the crucible for damage, because if you heat it up, it'll crack on you. So if you were doing this in the lab, you want to inspect it to make sure it's okay. The first thing you want to do is you want to take your crucible empty and just blast the heck out of it, because it's got residue in it. This is how you clean it out. You basically combust any chemicals, residual chemicals in there. You heat it up, and then you allow it to cool. Once it's cool, then you weigh it, and that'll be the initial mass of the crucible and the cover. Next, you take magnesium. You take a certain amount of magnesium. You kind of like use a steel wool, because what happens is that the surface of the magnesium is going to react with oxygen. So there's a coating there. It's going to be an oxide layer. You got to get rid of that, because that's not going to react with it's already the product. So you got to clean that out with steel wool. Then you weigh it. Then you kind of coil it up and put it in your crucible. Make sure that the crucible covers the jar so that the oxygen can get in there. Then you heat it up. Well, you heat it up with the cover closed, and then you open it up so that the oxygen can react with it. Then you add water so that the magnesium nitride chemical will convert over to magnesium oxide. And then you allow it to cool, and then you weigh it. Okay. Then this is typical data table. This is not the data table that you will be given. If you were in lab, I would have you do this experiment 3 times. So there's 3 trials. A good scientist will always do an experiment in triplicate, because that way they can do statistical analysis on it. When you guys see the data table later on, you only do it twice. So we have the mass of the magnesium, we have the mass of the crucible and the cover, we have the mass of the crucible, cover, and the compound. So the mass of the compound is basically 124.090 minus 120.060. That's that. Now I have the mass of the compound, I have the mass of the magnesium. The difference between these two is the mass of the oxygen. So here are other data sets for the 3 trials. This is what you want to do. You know the mass of your magnesium oxide compound, 4.030. You know the mass of the magnesium, therefore the mass of the oxygen is 1.6. What I'm going to do is take the mass of the magnesium, divide by the atomic mass of the magnesium to get the mole of that magnesium. I take the mass of the oxygen divided by the atomic mass of the oxygen, I get the moles of the oxygen. I can see that 1.002 is very close to 1 point. There should be a point right here, okay? Sorry, it's 0.1. Well, when you divide both by 0.100, you will get a 1-to-1 ratio. So these are both 0.1002 and 0.1000. So the correct formula for this would be MgO. Then you would write the chemical name. So that part was pretty straightforward, I hope. Okay, that's the easier part of the 2 experiment. The second part, let me clear my, looks like this. You basically have a copper chloride compound. And what you want to do is you want to figure out the formula of this copper chloride compound. And the way you do that is you take a copper chloride compound, and it's going to be in solution, and you react it with zinc, okay? And in the reaction with zinc, what will happen is that the zinc will displace the copper is free. And this solid is what you isolate in your synthesis. And then the zinc chloride is going to be in solution, or it'll burn off. Let me go back. Sorry, I keep hitting the wrong button. And then what you want to do as well is you want to wash any of the impurities with hydrochloric acid, so you have the copper in its pure state. So the 2 data that you guys are going to have in experiment 2 is you're going to know the amount of copper chloride that you start in the beginning, and you will know the amount of copper at the end. Okay. in this particular experiment, we use 20 milliliters, but for your experiment, you guys are going to use 15 milliliters. This is just to give you a sample calculation of what you guys are going to be doing. So you guys are going to have the end product is you've got copper, chloride, zinc, and this really should be copper, chloride. Okay, that's wrong. And what happened is that the zinc will kick off the copper, and the copper will form as a precipitate. Okay, then you wash it with hydrochloric acid so that the copper will be pure and it doesn't have any impurities. That's basically the idea behind this experiment. So let's take a look at the procedure, and you guys will see this in the video. You've got your solution. Generally, copper, when it's in its ion form, is a blue solution. When it's in its solid form, it could be either brown, if it's pure copper, or bronze. But if it's a different compound, it could be different colors, like the copper sulfide that I showed you earlier, that's black. Anyway, you start out with a copper chloride solution. You have a piece of zinc. You weigh the amount of zinc. You put the zinc into the copper chloride. What happens is that the zinc will replace the copper in the copper chloride compound, and the solution should start clearing up. This solution right here should start clearing up as more of the copper starts to precipitate out. Okay, then what you want to do is when the reaction occurs, you want to put hydrochloric acid to wash it out, and then you need to dry it. And you dry it over a hot plate. Make sure that no residual liquid is with the copper, and then you weigh it out. So this is what the data will look like. Again, 3 trials. You have a 1.1% solution of your copper. You're doing a 20.0 milliliter. So again, your experiment is going to vary from this, but I just want to show you the calculation that is involved. Let's see. Okay. So what we have is the volume. If you have the volume of the solution and you know the concentration of the solution, then you can figure out how much of the chemical you have. We weigh the mass of the zinc, and at the end, we weigh the mass of the copper. How do we get the mass of the copper? It's this product at the end that you weigh out. You're assuming that that whole thing is pure copper. Okay, so that's what we have right here. We have the data set, and then of course we're doing it 3 times. So what we're going to do is, let me go back so that you guys can see what's going on. We are going to determine the formula of this chemical right here. Whereas in the part A, you produce a product and you determine the formula. Here, you have a reactant. You don't know what the reactant is. You're going to determine the formula of that. So I just want to make sure that you're clear that this procedure is very different from part A. So what we want to do is we want to take the volume, the concentration, I mean, and if I know the concentration and I know the volume, then I can calculate, okay, the amount of copper chloride in my original solution. And how do I do that? I do that by saying that, okay, I've got this right here, 1.01 over 100 mils. That's 1.01%. Okay, that's 1.01%, because if you take 1.01 divided by 100 and multiply by 100, that's 1.01%. So you take the volume of the solution that you use, that's 20, and you multiply by this ratio, and now that's the mass of your copper chloride that you had in the beginning. In this solution, this 20 milliliter solution, you had 0.202 grams of copper chloride. I put X and Y here so that because you don't know what those values are. Okay, The mass of the chlorine now is going to be equal to the mass of the copper chloride, which we calculated right here, minus the mass of the copper, which was right here, okay? So the mass of the chlorine is that difference, and what you have is 0.072. Now that you have the mass of the copper right here and the mass of the chlorine, you can figure out the mole ratio for the two. So let's take a look at that. Let me erase this real quick. So this is the mass of my copper. I divide by the atomic weight of the copper, and I get the moles of the copper. This is the mass of the chlorine. I divide by the atomic weight of the chlorine, chlorine the atom. I get the moles of the chlorine. Now I have these as numbers. I look at which is the lowest ratio, and I divide by the lowest ratio and make these whole numbers. And that would give you your chemical formula for your product, for the starting material in part B of this experiment. Okay, I hope that's sort of clear. If it's not, go back to the video. I'll post it so that you guys can see what's going on. Okay, and then these are the post-lab questions. So at this point, I would say, all right, you guys find your partner and then carry out this experiment, and let's get to work. So that basically is it. Let me just show you now. Your screen should be changing because my slideshow is over. I'm going to take you back to Canvas. Okay, take you back to Canvas. Let me change that for you. I'm going to open it wide here. So under Canvas, that would be the pre-lab discussion. Go ahead and take the pre-lab quiz, answer the pre-lab questions, go over here to the data and worksheet. In the data and worksheet, you have two videos. The first video is part A. So if I just click on this, let me just give you a preview. There's always a commercial in the beginning. Let me fast forward this. Here is the experiment.
Balance. I'll do that right now. And we'll take the mass of that. So the mass of our crucible and cover. And
so they're basically just showing you what's going on.
Get in there. And we'll let that heat for about a minute or so, just to make sure all the magnesium.
So I'm going to stop because I don't want to rob you of your experience. The second part is this right here. This is the Jove video. And let's take a look. You can always increase this by clicking on this so that you have a full screen. I'm not going to do it here.
Determining the chemical formula.
I'm going to fast forward this so that you guys can see what's going on.
Then divide each component by
and it shows you as well the calculation.
The smallest whole number ratio yields the formula of copper to chloride.
So I'm going to stop here. So I don't want to, again, click on this data sheet. The data sheet is basically, if you don't have that in your lab manual, oh, sorry, take that back. The data sheet is your data. This is for part 1, trial 1, trial 2. You only need to do 2 trials here. This is for part 2, part B, trial 1, trial 2. So take this data and put it into your worksheet in your lab manual. This is the data that you guys are going to be using. Okay. So,
Professor?
Yes.
How are we submitting this?
I'll show you shortly. Okay. But make sure you write in your lab manual the same way as if you were in lab.
Okay.
Okay. So from this point on, everything is going to be written in your lab manual. So let me go back to the modules. Once you've completed watching the video and writing the data in your lab manual, click right here. This is your upload link. When everything's complete, go ahead and click on this. It's basically a, it's like a quiz, except it's not a quiz. This is where you find your file. Only your data and worksheet will be put through here. You find your file in your computer, you upload it, and then it'll be submitted. Okay, I hope that answers your question as far as your data. So this is just, What was that?
You wanted us to take a picture of our lab manual?
Yeah, the pages, the data sheet pages. Yeah,
Yeah.
take a picture and then compress it so it's one file. Okay.
Okay.
Then when you've uploaded that, that's only your data sheet. Then go to this page and upload your post-lab questions. Okay. This will be the place where you upload your post-lab questions. And once that's complete, then you're done. And so you can actually do this at any point during the week, but it's going to be due Sunday before midnight. Okay. So that basically is how we're going to be conducting experiments from this point on. Okay. And what you've seen here, this experiment is a trial run to make sure that everything runs smoothly. The other experiments down the line have not been modified yet, but over spring break, we will put these pages same as this week so that you know where to find the information, you know where to take the pre-lab questions, the pre-lab quiz, the videos and the data that you guys are going to be using, and then the links to upload your files. So this will be due Sunday. Make sure you turn in experiment 5, the post-lab questions, by tomorrow. Next week is spring break. Hopefully you guys will get rest and get accustomed to how the new format will be. And then when you get back from spring break, I would have all the experiments graded by spring break. And that week, all you guys are going to be doing is just, I guess it's another break until you decide to take the lab practical in the midterm. We don't start experiment number 7 until the week of April 14th through the 16th.